All right. So first of all, hello everyone. So this is going to be it won't take too long. This is just something that we at NXS do sometimes on Fridays. That we are talking about some a topic that is directly related to our work or possibly might be related to our work later on, or that is just interesting to us. And yeah, it's not something that's binding. It doesn't mean that if there's a topic, it's just it's not something that we have to do in the work. It's so we can talk about topics that we just personally are interested in and might not ever touch again. So yeah, if you don't care about it, just listen. Maybe you learn something, maybe you don't. But let's get through it. So today I wanted to talk a bit about GraphQL, and so we have previously talked about GraphQL at a previous NXS Jour Fixe, but we have never talked about it in the context of using it over an existing backend. And I think that's something that would be really interesting for the for endios 1 especially, because we already have a backend there. But I think that there's still value in using GraphQL, even though we already have a REST backend and it is working, but there are some advantages to using GraphQL. So I wanted to get through them. So hopefully the presentation is still ongoing, or did the screen go away for you? It's really hard to tell in GoToMeeting.
We can still see it. Yeah.
Okay. All right. So what's GraphQL? I keep this one short. I have a few slides and then I have a demo to show some secret stuff. So GraphQL is, so I just copied the Wikipedia text. It's basically an alternative to the REST approach to get and manipulate the data. But it shifts the responsibility from the backend to the front end, because one of the biggest differences to traditional REST backends is that there's only one endpoint. And so we don't have get apps and get application data and whatnot endpoints, just as a single endpoint. We always know it's the exact address, and but the queries and the data that's going to be manipulated is coming from the front end. So a GraphQL server needs to implement certain data sources where the data is coming from. And that is traditionally, the emoji is not working. That is traditionally a database. So similar to how REST backends work, where we have like a Node and Express server that is pointing towards a MySQL or MongoDB database. It's similar to GraphQL. It has databases as a data source. And then there's some special GraphQL magic like the schema and resolvers, where the schema is basically an interface and the resolvers point towards the data sources and connect it all together. And then there are queries that you write against the GraphQL API. But something that has recently come to life is the ability to use traditional already existing REST endpoints as a data source for a GraphQL API. And so this is what we are looking at today. And so in the, let's briefly talk about the GraphQL ecosystem and why it's really fun to use and really thriving at the moment. So there are basically two big GraphQL ecosystems that are supported and used by the community. Most of you probably know that GraphQL is a product from Facebook, similar to the React framework for the web. But most people don't just use the vanilla GraphQL library from Facebook, but most people use either Apollo or AppSync. And I want to briefly go through the differences. Both implement the GraphQL specification, but Apollo is mostly open source. It has the most advanced GraphQL clients and servers. It's available on most platforms. It's available for web, for Android, for iOS, for Internet of Things devices, and it has a lot of features. So GraphQL is a difference to REST is that you need to implement GraphQL on the server and on the client side, and from the same vendor usually. And but it offers a lot of features. It offers features like subscriptions, which some people might know from if you have experience with Google's Firebase, which is basically a kind of real-time get. So you can have an endpoint where, let's say you want to code a chat app, and you don't want to get all the messages. So you can create a subscription, and it's basically creating a WebSocket that's constantly being updated in real time with the latest messages. It also supports batching. We will see how that looks like in a minute. It supports, it has great support and integrated support for in-memory cache that we will all see in a minute. Apollo has also great integration for the popular JavaScript frameworks like React and Angular. I happen to like Angular, but I'm just as happy to see React projects over the next coming months. And it also supports offline and server-side rendering support. There are still many people who are baffled by the sound of offline support for web apps, but it's absolutely possible nowadays with the rise of progressive web apps. And there's also great debugging tools available for Apollo that I will also show in a minute. And on the server side, there's official support from Apollo for most function as a service from the public cloud vendors like AWS Lambda and Azure Functions and Google Cloud Functions. And you can even use Redis or Memcached or AWS Elasticache for a shared cache on the server side, so that if you have data that isn't constantly changing, like weather data in your city, and 500 people are asking for that weather data, then it doesn't make sense that it's reading from the database all the time. You can put your GraphQL server on a Lambda function somewhere and use a Elasticache shared cache, and the first user will trigger a request to the database, and the next 400 users will just get a response directly from the cache. And there's also something called Prisma, which is not part of Apollo, but it's also a very cool add-on to connect databases to Apollo. It's basically like so we are using a lot of Mongoose to connect our REST backends to a MongoDB database. And Prisma is a similar layer to several databases to your GraphQL server if you happen to implement GraphQL server natively. And so I said it's mostly open source because there's a proprietary project from Apollo called Apollo Engine. That's where the money is coming from. And Apollo Engine is basically like a managed dashboard where you can it's similar to how we use Postman, where you can see statistics and performance data and can play around with your GraphQL API. And so Apollo is what we are going to focus today, and what I will show you in a minute. But I wanted to briefly mention Amazon's AppSync, because it's also really fun to use, and it's proprietary. It means you are vendor locked in with Amazon. That's always a point of discussion, but the upside is that it's super easy to get started. You don't have to manage any servers, and they also have an SDK to integrate the Apollo client with an proprietary AppSync server. But they also have an own library called AWS Amplify, which is the library that you use on the web, Android and iOS, to use the more mainstream Amazon services on the front end. And I'm pretty sure that we will see AWS Amplify somewhere in the one ecosystem, because yeah, even for stuff like getting and putting data in storage buckets, it's all growing towards AWS Amplify nowadays. Something really cool from AppSync is that they have additional integration with their own database and Elasticsearch, which means that you can create a schema in the AWS console, and it will automatically create a database and connect towards it, and it will sync with an Elasticache, and you don't have to do anything. That's really well integrated, but it's proprietary. So that's always a downside and an upside. All right, but the topic of today is Apollo with REST. And yeah, like I said, this is something that has been possible recently. It's possible with both Apollo and AWS AppSync, and it basically means that you don't connect to a database, you don't use something like Prisma, but you just point your GraphQL API towards an existing REST backend. And so, without further ado, let's just look at some stuff. So I've prepared a small demo, and it's actually using endios. And it's not just mock data, it's actually the real endios API. So let's start with the server. I'll try not to bore with too much code, but I want to briefly show what it looks like, and then show some cool stuff that you can do with GraphQL. So first of all, we have a very, very small GraphQL server right here. I partially implemented the existing endios1 backend, just two calls, and I've used the Apollo server, and it's absolutely standalone. It's not using any integrations with other web services. No Lambda, no Node Express. It's just the bare Node application, and it basically consists of the schema. This is a GraphQL schema. It always looks like this, where you define some of the entities that you have. Like the only things that we will focus on today is are apps and app configs, which are also part of the endios1 API. So some of you might be familiar with them, and I've just partially implemented it. So from the app, which is the get apps call in the endios1 backend, I've implemented active, description, ID, name from app config, a few of the fields, and page style and widgets are also represented with a few fields that I'll show you in a minute. And so the actual queries that we are allowing are written down here. It's get apps and get app configs, which are both mapped on that's the GraphQL resolvers, which are mapped towards the API that we all know from endios, and it's not mock data. It's actually going against API test endios.de, and the customer apps and customer apps configs endpoints. But we will show something interesting because we just have 2 endpoints towards, but we can still do more than that. And I'll show you that in a minute. So that's basically all there is to the GraphQL server. It's getting way too big now. Okay. So it's a schema. It's a resolver that says, okay, the query goes towards this and this HTTP endpoint, and we are sending an authorization header, and we are starting the server. And that's our complete GraphQL API right now. And on the client side, which is the endios dashboard, we needed to implement, first of all, we need to import the Apollo client, and we are also importing a memory cache and a batch module from Apollo and set this up. So if you have ever seen an Angular web application, this will look familiar to you. It's basically, most of it is automatically generated. The Angular CLI sets this up nicely. Apollo has nice integration with Angular. And so the interesting part is this one. I'll show you the page in just a minute. And yeah, let's look at the actual page. So both the server and the demo that I'm going to show you are both publicly available if you have access to the naccess Bitbucket. If not, if you're interested, you can ask me later. But it's part of the one dashboard, and there's an experimental GraphQL branch where you can check it out if you want. And so we have this new menu item GraphQL demo right here, and there are I've prepared some queries that show some very interesting characteristics. So first of all, what does a GraphQL query look like? Well, what we usually do is we have an HTTP service that has a lot of functions like get apps and get application data, which is going towards the specific endpoints. But since we only have a single API, which is just localhost in this case, we don't need that. So we don't even have a service. But something that is typical to do is to prepare some queries and put them in some directory like here. And this is basically what a GraphQL query looks like. It's just one of the functions that we defined in our server. So we defined get apps, which pointed towards the REST get apps endpoint. And then we basically just say, okay, which parts of these do we actually care about? So that's what we mean when we say that the responsibility shifted towards the front end, because now we are in control of what data we actually receive. And so if I'd do this query, and then I already know beforehand what I'll get. So this is the one, and the console is not getting bigger. It is. So in our query, we asked for active and description short ID and name from the get apps, and that's exactly what we got, and we got both of them. But let's say that we have some table and we don't really care about descriptions and active and IDs. We really just want to see the name of all the apps that we have. It's let's say we are on mobile and the connectivity is bad, and so it's just a waste of bandwidth. So we would just change our query and make it look like this. We would still use the get apps function, but we'd ask for just the name. And if you do that, then It does just what it says on the tinfoil. It just gives us the name, One and SunPower, which are the apps that are on the endios test API right now, and we don't waste any bandwidth and resources on the server. And it's the same thing with get app config. It's a bigger query, it's more data, but it's working similarly. And this is all stuff that you can do with REST as well. But no, let's try some things that are not really possible with REST or not as easy. So let's say, and this is quite a common situation, that we need more data at once. Let's say we have we want to know all of the apps that endios offers, and we want to know the app config from one of the apps. So usually that would mean that we had to do two GET requests towards the backend. One for, hey, get me all of the apps, and one get me the app configuration for the second app, for example. And that's really inefficient, but it's unfortunately it's quite common. But GraphQL allows us to work around this in multiple ways. So the first one is we can just combine a query. So this is really cool. We can in a single query we can call multiple functions on the GraphQL API, like get apps and get app configs, and we are passing a parameter, and that allows us to just use a single call. And I promise it's just a single call. And with a single call, we can, and this is what it looks like. With a single call, we get the data from get apps and get app configs, which is much faster, especially on mobile and in scenarios where you have a bad connection, which is really nice. You can combine as much queries and mutations as you want. Mutations, by the way, is the way to manipulate data in GraphQL. Is basically like a post or a patch in REST, but we are only doing queries right now. And so you could have a query where you ask for lots of data that would usually require dozens and dozens of endpoints all in one. And but there are even more benefits to the performance with GraphQL. So let's say we have, let's say we initially just cared about the apps. So we asked for get apps. And later on, we also needed the app configs. So we get the app configs, and that's obviously the second call. And now at some point later, we need both the apps and the app configs, but we already asked for both of them in different calls. But if we now ask for the apps and the app configs in a combined call, you will see that there's no outgoing connection. And why is that? It's because the GraphQL client knows that we already previously asked for apps, we asked for app configs, and now it doesn't need to go out because it knows it has all the information. And so we get all of our information without any network requests, which is, of course, really fast. And of course, we have full control over the cache. So if there's time-sensitive data and or we need to have the latest configuration, then obviously we would not cache. But there are a lot of scenarios where it absolutely makes sense to cache. For example, the widget core set that is not specific to any apps, but the overall widget core set is not changing every second. So it makes sense to cache there. And so this is also very cool, but there's even more cool stuff. It also allows batching of queries. So what's batching? It means that sometimes we need to have different information, but we don't combine the queries in a single call. But maybe we have a situation where we have two separate HTTP calls to the backend, or to the GraphQL API, and they're both milliseconds apart, and but it would still be 2 calls. And the GraphQL API and client allows batching, and you can set a time span where the queries are batched, which means that in our case we have a scenario where we where we try to send out 2 requests in a very just milliseconds apart. And what's going to happen is it still sends out just 1 single request, even though in our actually Angular application, it's 2 completely separate requests. But because we are using a Apollo batch link, it knew that the time between the 2 requests is so close together that it batched our requests together automatically. And while they're individual requests, it's just 1 HTTP request, and it's much faster, and it's also a scenario that we have very often in our applications, that we have basically a request, and once we get the reply, once we get the response, that we send out another request, and it's really wasteful. So this is also something that is just automatically handled for you, and is just really performant. And so these are just some of the performance characteristics. There are a lot more. For example, you can as I pointed out, set up your GraphQL server with a shared cache like Memcached and Redis to further improve the performance. And you can also persist the state and the data that you get offline or in local storage, so that if you close the browser and you come back later and go on the site, that it will rehydrate the state and does not need to send out HTTP requests if the data is not going stale so soon. And this is there are a lot of community projects around the Apollo clients that really help with performance. But these are not the only benefits. I also want to briefly show some of the debugging tools, because so usually there's similar to the state management with Redux. There's also a Apollo browser extension. I don't have it installed right now, but it's similar to what I'll show you anyway. And this is called GraphQL, and it's basically the out-of-the-box debugging experience for GraphQL, and it's just like what it looks like here. You can just, it's basically a console where you can just fire away and see what works and what doesn't work, and it already came with the Apollo server that we set up. It doesn't need any additional code. It's just out of the box, and we can fire away our calls, get the answer. And because we have a schema, it also gives us auto completion. So it shows us we have the get apps and get app configs method implemented by our GraphQL server. We say get apps, and now it tells us, okay, which fields do we care about? Okay, maybe we only care about ID, and we care about, I don't know, maybe about the name. And we can just fire this and see, okay, this is the response. This is what I wanted. Now I can go back to my Angular application and implement this. Or I can implement a dynamic query where I implement just part of the query, and the rest will be dynamically generated by whatever the action of the user is. If he clicks on app 1, app 2, and so this is really, really, really powerful debugging experience right here. And this is also persistent. You have a history of previous queries, and you can also enable tracing on the server. So if you really care about your performance, you can send out a query. You see exactly, okay, how long did it take to get to get this field and to resolve this function and another function. And you can also see that if you run a query again, and it's already cached, that the response time is going down. And this is also just, it's just integrated. It's completely part of the Apollo ecosystem, and it's really much more fun to use than let's say a Swagger and Open API type of REST debugging, which really sucks, to be honest. And yeah, so this is basically what you can also expect if you install the Apollo browser extension and just go on your site. You can also see which key values are cached there, and which will be fetched by a query and why, and if the cache is stale or not. And it's overall just really fun. So this is everything that we implemented for the on the client side for GraphQL. It's basically just calling the Apollo service, which has a special integration for Angular, and we just tell, so all of these buttons that we saw here are basically just giving strings and calling a function here, and the string is just get apps or get app config or something else, and we just pass it to our GraphQL API and get the results, and that's all we did. It's really simple, and I'm already taking way too long, so I'll come to the end. And yeah, I don't think I have any more slides. So yeah, so for those of you that have access to the NAccess Bitbucket, and if you are interested, you can play around with it. It's part of the experimental branch of the one dashboard. The server is also included in this. And but that's all for me today. There's a lot more cool stuff that you can do with GraphQL. We really just scratched the surface. There are lots of upcoming community projects for to persist state, to integrate it with different frameworks, to further improve performance and debugging. You can do all sort of crazy stuff. You can have resolvers do part of the authorization. You can combine different data sources. It's really a lot of fun. So I just wanted to talk about this because I think it's not too late to maybe still think about at least offering the option of using a GraphQL API instead of the REST backend. And I also wanted to mention that it's completely also working on Android and iOS. It's not just a web thing. So I don't really know what the network layer on the mobile apps is right now, and which backend they are talking to. But it's just something to keep in mind. If offline connectivity or bad connectivity and performance is a problem on mobile, GraphQL can definitely help there. So thanks for your attention, and yeah, have a nice weekend. Any questions? I see everyone is just as shy as me.
No, thank you for showing us all this cool stuff. Like, how long did it take to set up the server actually for you? To set up the example?
Honestly, like 2 hours maybe. I just went through the Apollo tutorial and just implemented the REST data source, and it really didn't take longer than like 2 or 3 hours maybe. All right, if there are no other questions, then I'll leave it at that. And maybe someone else from Hamburg wants to do another presentation about something cool they like or would like to see in endios, or just think would be cool to show. So we should try to do these kinds of talks like every second Friday or something. Maybe it would be fun. So have a nice weekend and bye.
I have a quick question. Where can we find this video later or the slides?
So
we'll probably announce that on the Slack channel. So we have no place right now, so we'll let you know on the Slack channel.
So the last time I put it unlisted on YouTube. So if it's behind some kind of wall where some people don't have access to, that would be another option to just put it on YouTube.
Yes, okay.
Any more? All right. Then goodbye and have a nice weekend. Bye.
Goodbye.
Bye-bye.